Hello everyone, welcome to this video. In this video, we are going to see how to solve the type 3 form of homogeneous linear PDE. So in type 3 form of linear PDE, in the right hand side, we may have our function in this form like x power r into y power s, so which is nothing but a polynomial function. So if you have a polynomial function in the right hand side, how to find the particular integral, that is what we are going to see in this video. So first here, for finding the particular integral, we first write the function in the numerator and the function of d comma d dash in the denominator, after which we are taking this denominator term to the numerator and this should be expanded as a binomial series, and operating this polynomial function on each term of the binomial expansion, we can get our particular integral. So now we'll see some examples to this. So this is our first example. See the right hand side, which is not a type 1 or type 2, because type 1 is exponential function and type 2 is trigonometric function. But here in the right hand side we have a polynomial function, that is which is a type 3 function. So first we are going to find the complementary function. For finding the complementary function, first we write the auxiliary equation, that is replacing in the left hand side, replacing d by m and d dash by m, we get m square plus 3m plus 2 is equal to 0. And solving this, we can get the roots, and the roots are here. It is m plus 1 is equal to 0 and m plus 2 is equal to 0, and so the roots are m is equal to minus 1 and minus 2. So for this case, the complementary function is written as phi 1 of y minus m1 x, that is minus x, plus phi 2 of y plus mtx, that is y minus 2x. So this is what our complementary function. So next we are going to find out the particular integral considering the right hand side function. So in the right hand side we have a polynomial function. So we have to take our function in the numerator and the function of d comma d dash in the denominator, which is d square plus 3d d dash plus 2d dash square. So first we have to write the denominator function of d comma d dash as 1 plus function of d comma d dash or 1 minus function of d comma d dash form. Then only we can expand it as a binomial series. So I want 1 as the first term, so I'm taking d square outside from this denominator term. So from this I'm getting 1 plus 3 by 3 d dash by d plus 2 d dash square by d square. So this is what our x term. So now I can take this to the numerator, that is my particular integral is x plus y, and that is it is 1 plus 3 d dash by d plus 2 d dash square by d square. This is what my x term, the whole inverse of x plus y. So now I'm having 1 plus x, the whole inverse form. So I can expand it as a binomial series like 1 minus x plus x square minus x cube plus and so on. So now expanding this 1 plus f of d comma d dash, the whole inverse in the series expansion, I'm getting, actually we have 1 by d square here. So it is 1 by d square. First term is 1 minus x. So it is 1 minus 3d dash by d plus 2d dash square by d square plus x square term. I don't want x square term because here I can find maximum one derivative of this function. So I no need to show that the x square term explicitly in this series expansion. So it is plus and so on of x plus y. So now I'm going to operate this function on each term of this series expansion. So it is 1 into x plus y is x plus y minus 3 into d dash of x plus y. D dash of x plus y is, d dash means what? First I'm just taking d dash. D dash of x plus y means dou by dou y of this term is only 1. So it is only 3 by d Next minus 2 by d square, and d dash square of this term becomes 0. Okay, so I'm having only this. Okay, 1 by d square we have outside the bracket. So which is equal to 1 by d square of x plus y. So 3 by d means 1 by d. 1 by d means integration with respect to x. So from this we get 3x. So it is 1 by d square of x plus y minus 3x. 3x, 1 by d means integration with respect to x. So we get 3x here. So now we have to integrate the whole function with respect to x 2 times, because it is 1 by d squared we have in the denominator, because we know d means dou by dou x and d dash means dou by dou y, and if we have 1 by d means it is integration with respect to x, and if we have 1 by d dash means it is integration with respect to y. So now I'm going to integrate this with respect to x. Okay, so which means here I'm getting x square by 2 and it's a constant. So y into x minus 3x square by 2, and again if you integrate this with respect to x, I'm getting x cube by 3 into 2, that is 6, plus y into x square by 2 minus 3 into x cube by 6. That is finally my particular integral is x square y by 2 plus, here I'm having x cube minus here 3x cube, so which is nothing but minus 2x cube, 2x cube by 6. So this is what I'm having here. So finally my particular integral is x square y by 2 minus x cube by 3. So finally we can write our complete solution as CF plus PI. So this is what our second example. So in the right hand side we have two functions. One is type 1 function and the second one is type 3 function. Type 3 function. So now as usual we are going to find out the complementary function first. For we consider the left hand side, and in that we are going to replace d by m and d dash by 1. So it is m square minus 2m is equal to 0. So taking m outside from this we get m minus 2 is equal to 0, and from this we get the roots as 0 and 2. So now for this case the complementary function is written in this form: phi 1 of y plus 0x, that is y, plus phi 2 of y plus 2x. So now let us come to the right hand side. So to find the particular integral, here we'll consider first function. So correspondingly the particular integral is taken as particular integral 1. So now I'm going to consider only the first function, that is an exponential function. We have an exponential function in this form: e power ax plus by. And in the denominator we have the function of d and d dash as d square minus 2 into d dash. So here for type 1 function we know that we are replacing d by a and d dash by b. So here d is 2 and d is replaced by 2 and d dash is replaced by 0, because we have here ax plus by as 2x only, means a is non-zero and b is 0. So replacing d by 2 and d dash by 0 in the denominator we get simply it is e power 2x by 4. So this is what our particular integral 1. So our particular integral 1 is e power 2x by 4. So next we are going to consider our second function, that is x cube y. So our particular integral is for x cube y, it is d square minus minus 2d d dash is our denominator term. So first we have to express the denominator as function of d comma d dash form. So it is taking d square outside, we can write this is 1 minus 2 d dash by d. So now we have to take this to the numerator. It is 1 minus 2 d dash by d, the whole inverse of x cube y. So from this we get 1 by d square of, now expanding it as a binomial series, it is 1 minus x plus x square, that is 4 d dash square by d square plus x cube. Actually from x cube onwards we can't find the third derivative of this function because it becomes 0. And also for y it becomes 0 since the numerator is d dash. So it's enough to show only the first three terms in this series expansion. So the next term would be minus x cube. So it is 1 minus x plus x square minus x cube and so on of x cube y. So now I'm going to operate this x cube y on each term of this series expansion. So it is 1 into x cube y is x cube y minus 2 by d, and d dash of this, d dash means dou by dou y of this term is x cube, plus 4 by d square, and d dash square of this term becomes 0. So from this we get 1 by d square of, it is x cube y minus, here 1 by d of x cube means integration with respect to x. So it is x power 4 by 4. So which is 1 by d square of x cube y minus x power 4 by 2. So now we have to integrate this with respect to x twice. So we get x power 4 y by 4 as the first term when you integrate this once with respect to x, and the second term is x power 5 by 10. So again we have to integrate this with respect to x because we have 1 by d. So now integrating this again with respect to x, we get x power 5 y by 5 fours are 20 minus x power 6 by 60. So this is what our particular integral to. So finally we can write our complete solution, that is CF plus PI1 plus PI2. That's it. So this is our next example. So here also we have two functions the right hand side. The first one is type 2 function. It's a type 2 function, and the third one is, the second one is type 3 function. So here as usual we are going to find out the complementary function first. So it is on the left hand side, if we replace the d by m and d dash by 1, we get the auxiliary equation is, so the auxiliary equation is m cube minus 2 m square is equal to 0. So now we can take m square outside from this, so it is m minus 2 is equal to 0. From this we get the roots as 0 comma 0 comma 2. Therefore the complementary function is phi 1 of y plus m1x, that is y plus x into, we have equal roots, first two are equal, so it is x into phi 2 of y plus 0x plus phi 3 of y plus 2x. So this is what our complementary function. And considering the right hand side, and if you consider the first function and you know how to find out the corresponding particular integral because it is of type 2. So now let us concentrate the second function because it is of type 3. So now I'm going to consider only the second function and I'm going to find its corresponding particular integral. So let it be pi2. So it is 3x square y by, the denominator term is d cube minus 2d square d dash. So first we have to write the denominator term f of d comma d dash as 1 plus f of d comma d dash form or 1 minus f of d comma d dash. So I want 1 as the first term. So I'm going to take this d cube outside from the denominator. So it is d cube of 1 minus 2 d dash by d. Okay, so which is nothing but equal to 1 by d cube of 1 minus 2 d dash by d, the whole inverse of 3x square y. So now we have to expand it in a binomial series, and then we have to operate that function of x and y on each term of this series. So it is 1 by d cube of 1 minus 1 minus, and here also minus. So in the series we have only positive sign because it's a positive series, then because we have two negative signs. So the series is a positive series, and it is 1 plus x is 1 plus 2 d dash by d plus x square is 4 d dash square by d square. So maximum we can find only d dash square, and d dash square also not possible, so we can stop here. So the next term would be x cube, 1 plus x square plus x cube and so on of 3x square y. So now operating this 3x square y on each term of this series expansion, we get it is 1 by d cube of 3x square y plus 2 by d of d dash of the term. D dash means, so it is our function of x and y. D dash means dou by dou y of this term is 3x squared. And in the next term we have d dash square means dou square y by dou y square cannot be found out for this function. Since we have the power of y is 1, so that becomes 0. So from this we get 1 by d cube of 3x square y plus, it is 1 by d of this term is 6, so x cube by 3. Now we have to integrate this with respect to x 3 times. Here we get 2. So when you integrate this with respect to x one time, we get it is 3x cube by 3 into y, and in the second we get 2x power 4 by 4. So we can cancel this 3 here, and here it is 2. So again we have to integrate this with respect to x. So this comes as 6x power 4 by 4 into y, plus here it is x power 5 by 10. And again we have to integrate this with respect to x, means this comes as x power 5 by x power 5 y by 20, and this comes as x power 6 by 60. So similar to the previous function, we have got the same result as particular integral 2. And finally the complete solution can be written as, complete solution is z is equal to cf plus pi1 plus pi2. I hope you understand these. Thank you.